So this lesson here is going to take a couple days, and we're going to discover the Pythagorean theorem, which is the whole purpose of investigation 3. All right. So for our directions for these tables that you see below, it says decide which type of triangle is shown. Justify right triangles. And what's our rule if we know something is a right triangle? What tells us that two lines meet at a right angle? Stephen, right? What's our proof that they're 90 degrees? Yep. Opposite or negative reciprocal slopes. So that's how we're going to justify the right angles with negative reciprocal slopes. Okay. So here's how we're going to do that. We're going to do the first one together, and then we're going to kind of let you do one and pause and do one and pause. And if you notice, there's 3 on the front side and 3 on the back. All right. So this is quite a little lengthy exercise. So it says label the sides of the triangle A, B, C, D. A being the smallest side, B being the medium side, and C being the longest side. So if I go down to the first part here, all right, I can tell this is only 1, 2. So this is A. I'm going to have to change my pen length here just so you can see it because I have to write tiny. Yeah, let's shrink this here. All right, so this is A, that's B, and that's C. Okay. So it says draw squares on each side of the triangle. Well, this one's a little easy because if this is 1, 2, 3 high, I got to make all my lengths 3, right? Which is just like this. And we'll humor this. We'll make each square a different color. So let's go up a little higher so we can see. So we'll make each square a different color here. And this is 1, 2, 3, 4. So I'm going to go down 1, 2, 3, 4. Now my last one's going to be a little more tricky, right? Because I got to figure out, I got a diagonal here, right? So just like in that quiz that we took, right? To make a square, I got to find the slope. So it's going down 1, 2, 3, and over 4, right? So I'm going to do some work here off to the side here. I'll erase this eventually, but yeah, off to the side, I'm going to do C as negative 4/3, right? So this line here is negative 4/3. You with me? All right, we're going to do this one in blue. All right, so this line right here. So to go upwards, I got to go up 4. 1, 2, 3, 4, and over 3. That puts me right there. And I'll try to draw this as straight as possible. 1, 2, 3, 4, and over 1, 2, 3. Because remember, negative reciprocal slopes, right? I should be going actually up 3 and over 4. My bad. Right, because the negative reciprocal slope of this is 3/4. So 1, 2, 3. So here. Okay. So there are my 3 squares. So it says we're going to find the area of each square, and by finding the area of each square, we should be able to find the sides, the side lengths. So this first square here, where side A is, the green one. All right. What's the dimensions of that square? What's the dimensions of this little green square we drew right here, next to side A? Jamie? 3 by 3, right? So if it's a 3 by 3 square, what's the area? 9, right? So the area here is 9. The area of that square is 9. So the small square, that's the green one, the small square, the area is 9, right? All right, so how am I going to find the side length then? How do I know how long the side A is if my area is 9? Remember we did this with all the tilted figures, we found the sides? Jamie? And we know that because we can take the square root of the area, right? So to find the side length, we're going to take the square root of 9, which is 3. So our A side is 3 units. All right, so let's look at the medium one. That's side B here. What's the dimensions of the red square? Mine here. 4 by 4, right? If it's a square, all 4 sides are the same. This is 4 by 4. So what's the area of a square that's 4 by 4? 16, right? So this is 16. That's the medium, right? That's the medium square. Okay? So, with the medium square, if it's 16, what's the side length? What's the side length? Nice part about this one with horizontal and vertical lines, we can just count, but we want to get you in the habit of Blake. 4, right? Because we would take the square root of 16, which is 4. So the B side is 4. I'll get rid of that from earlier. All right. So now we got to find the shape of the square that's on a diagonal. The other ones were nice and easy, right? Because they were perfect squares. Remember in 2.2 we did the whole square thing? Whether they're perfect squares or tilted squares. So with the tilted square, how do we find the area of that square? What do we do in 2.2? It's actually 2.1. We had a square that was tilted. How do we find the area of the square that was tilted? Not everybody at once. How do we find the area of the square that was tilted? We did 2.1, and they weren't perfect squares because we just couldn't count 1, 2, 3, 4, 1, 2, 3, 4. To find the area, it was slightly tilted. They weren't perfect squares. What did we do? You know, we boxed it in, right? So this is kind of the hard part, but we're going to take this guy here, and we're going to just focus on the blue one. We're going to box it in. So the first thing we're going to have to do is figure out, okay, what is the area of the big green square I just drew? So let's count dots. 1, 2, 3, 4, 5, 6, 7. It's hard to see the dots. 8. Looks like 8. Yeah, that don't look like a square though, doesn't it? All right, let's go back to our diagonal. Let's see if I can go back to my black line here, so I can see a little better. I might have drawn the square wrong. All right, so let's look at our slope first. How many points am I going down? Yeah, that's what we did. 1, 2, 3. We're going down 3, right? Over 4. So this has to be 4/3. So actually, the square I drew the first time was right. It's all right. That's why you do it in pencil, right? Those you did in pen should know better. 1, 2, 3, 4, 1, 2. So that was it right there. Okay. So now if I box this guy in, and since we drew it in green, we'll try to do it in a different color so you see it. All right, so if I box this guy in, that square looks better. All right, so we are over 1, 2, 3, 4, 5, 6, 7. And we're up 1, 2, 3, 4, 5, 6, 7. So this big blue square is 7 by 7. Okay? Everyone agree with that? So if I have if the big square that I boxed in is 7 by 7, what's the area of that? 49. Good. Okay. And I remember I'm gonna have to subtract all these triangles, right? Remember, to find the area of the irregular square, the one that doesn't sit nice with vertical and horizontal lines. Well, all these triangles are 1, 2, 3 by 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So they're all 4 by 3, which is nice. So if I find the area of one of them, I'm going to find the area of all of them. So let's do this guy right here. All right, its base is 4. So what's half the base? So what's half of 4? 2 times the height, which is 3. 6. So all these are 6. So if I got 4 triangles that are 6, that means, how much is that total? 24. So we're going to subtract 24 from 49, which gives us what? 25. So the area of this guy is 25, right here. So this square right here is 25, okay? So if the area is 25, what's the side length? What do we do to these, the medium and the small one up above? Jamie's the only one who wants to talk today? Sheridan. If we have the area here is 20, here was the area was 16 and 9, right? Actually, I should have probably wrote 16 there. How do I find the side length of the area is 25? Huh? Not divide. What's the symbol? What's the symbol right here? Square root. So if we take the square root of 25, we get 5. So C is 5. Now again, how do we know if it's a right triangle or not, right? And that's what it asked us. We found the squares. So look for patterns in the relationship for the areas of squares. Well, these all happen to be the areas, right? The side lengths ended up being square roots of perfect squares, right? Square root of 9, 16, and 25, right? So the length of this triangle is a 3, 4, 5 triangle. Is it a right triangle or not? Is it a right triangle? Why? Yes is the correct answer, but why? The right angle is always opposite the diagonal, right? Well, what two lines meet opposite the diagonal? This is a special circumstance, right? We don't have to find opposite reciprocal slopes because those two lines are certain conditions. What? It's a horizontal and a vertical line, right? How many times we say how when a horizontal meets a vertical line, it's always a right angle. So it's yes because a horizontal line meets the vertical line. When you have undefined slope and zero slope, that's kind of opposite reciprocals of each other. It's kind of goofy to think of it that way, but when a horizontal line meets a vertical line every single time, that's going to be a right angle. And again, this was also a right triangle because, if you think about it, weren't all these guys here, these guys were all whole numbers. Horizontal, this is a perfect right triangle, right? Well, if we look at the next one, that's a little different, isn't it? Yeah, it is. So here's what we're going to give you guys a chance to do. I want you to take a few minutes and find the squares. So I want you to draw your squares. All right, there's only one line that's a straight line, right? So everyone else, to draw a square off it, you got to count the slope. So find your small side, find your medium side, just like they did up above, and your large side, the longest side. All right? And see if you can go about drawing your squares and finding those areas. All right? We're going to give you about 7-8 minutes. So we're going to pause. All right, well, if I drew a box on this side, would this side be the small side, the medium side, or the long side? Blake? It would be the medium, right? And that's a square. That's a perfect square, right? Horizontal, vertical lines. What's the dimensions of that square I just drew? Blake? 3 by 3, right? And if it's a 3 by 3, that area of that square is 9. So the medium square has an area of 9, right? So to find the side length, right, what do? We can take the square root of the area, right? Square root of 9 is 3, because 3 squared is 9, right? So this is the medium side is the B side, right? So B equals 3. So this side right here, okay? Now to find out, we really don't have a right triangle here, because if this is a vertical line, that means that this line right here, I'll draw it in red, I'll draw it in green. This line right here would have to be a vertical line for us to have a right angle, right? Is that a vertical line? No, that line comes in, which means that angle is less than 90 degrees. What kind of triangle it doesn't have a right angle? It's less than 90 degrees. Anna? It's an acute triangle. Okay? So, this little green guy here, this line has a slope of, this is the small side, right? Would you agree? All right, so up 2 and over 1. Which means if I'm going to draw a square off of this, right? I got to make it negative 1 over 2, right? Well, I can't really do negative 1 over 2 because that's going to draw a square in here. But if I work backwards, right? Up 1 and over 2. Up 1 and over 2. Because I went to the left, it's still negative. And there's my little teeny tiny square. So if we want to figure out the area of this side, the length of this side, find the area of this little square, which again is a 3 by 3, right? 1, 2, 3, 1, 2, 3. So that's 9. But now, these little guys in here are 1 by 2, right? 1 by 2. So those are all 1 by 2 little triangles, right? Well, if half the base is 2, what's half of 2? Times 1. So all those areas are 1, right? So 9 minus 4 is 5. So if the area is 5, right? What have we done to find the side lengths? Taking the square root of it, right? So if the area is 5, the side length is the square root of 5, right? That's not a perfect number, isn't it? So we're just going to say that A is the square root of 5 instead of writing the decimal form. Because remember, it goes on forever. So B, nice whole number. A, not so much, right? All right, well, that just leaves us the last side. Side C, the longest side, right? And again, we'll do that in a different color. So side C is right here. So to find it, I'm going down 2 and over 2, right? So what's the negative reciprocal of negative 2 over 2? Huh? 2 over 2, because we flip, it's the same number. So it's just going to be 2 over 2. Oops. So we're going to go up 2 and over 2, up 2 and over 2, and then so here's our square there to find the side length of that diagonal. And if we want to box this guy in, this square is a 1, 2, 3, 4, a 4 by 4. What's the area of a 4 by 4 square? 16. All right, and if these little triangles here are 2 by 2, right? 2, 2, 2, 2, all the way around. So if half of 2 is 1, and we multiply it times 2, each area is 2. And there's 4 of them. So what are we subtracting from 16? 8. So if the area is 8, what's the side length? Is 8 a perfect square? Well, no, it's not a perfect square because look at it's on a diagonal, right? The square is tilted. So if the area is 8, what's the side length? Like up here, the area was 5. What was the side length? Square root of 5. So if the area is 8, what's the side length? Square root of 8. So if you noticed here, this one was a right triangle. One of the things you saw was that all the sides were nice, perfect lengths, right? Here was not a right triangle, right? Look at 2 of the sides they're irrational numbers. They're square roots. They're not perfect, right? If you find the decimal, they go on forever. So they don't work out real nice, do they? All right. Now, if you look at the third one on the page, all right, none of those, we don't have any vertical or horizontal lines at all, do we? So this one's going to make us work a little bit. So which side would you say the medium side is? If I drew colors for each one of these, here, let's do this one. We'll do this one. So which color would be your small side? Which color would be your small side? Blake? All right, everyone agree red? Okay, so let's work the red first. Side A. All right, so from this point here to this point down here, we're going down 1, 2, 3, and over 2. So it's got a slope of -3/2. So what's the opposite reciprocal of -3/2? Anna? 2/3. And again, if I go up 2 and over 3, I'm drawing a square the wrong way, right? So I got to work backwards. So I'm going to go down 2 and left 3, which puts me here. Because that ends up being down 2 is -2, and left 3 is -3, so -2 over -3 is still 2/3, right? So I can go this way and make my box. Down 2, left 3, there's my box. So again, there's my square, right? I should know right now that that's not a perfect square, right? So the area, when we find a side length, that side length's not going to look very pretty, is it? Because the square is tilted. Remember, we learned this from Investigation 2.1. So let's draw a little box around this guy. This one's gonna look fun when we're done with it. All right, so this square is a 1, 2, 3, 4, a 5 by 5. So the big square is 5 by 5, which has an area of what? 25. And we're going to subtract out all these little guys here. All right? Which this one has an area of 2 by 3. Is a triangle. It's 2 by 3. So half of 2 is 1 times 3. So each of these are 3. And there's 4 of them. So how many total is that? What's the total area of the triangle? If each triangle has an area of 3, and there's 4 of them, that's 12. So 25 minus 12 is, right, 13. So if the area is 13, what's the side length? Square root of 13, because it doesn't come out to an even number. Right, up top, we got the square root of 9. We didn't have to leave it as square root of 9 because we all know that square root of 9 is a nice whole number, right? 3. Well, this isn't a nice pretty number, isn't it? You don't know it off the top of your head. So the square root of 13. So the side length is the square root of 13, which is a number between 3 and 4, decimal. So what length is the medium one? What color? Green? Yeah, green. That looks shorter than that one, right? All right, so let's pick up our green one. And this has a slope up 1, and then 1, 2, 3, 4, 5, 6. So 1/6. So how do I find the negative reciprocal of 1/6? Right, -6 over 1. So down 6. 1, 2, 3, 4, 5, 6, and over 1. Here. And 1, 2, 3, 4, 5, 6, and over 1 is here. All right. And unfortunately, I think we're going to finish right in the middle of this. But here, this is a big old square here. I will finish up this. We at least got to finish up this problem. So I'll finish up this video and we'll pick it up here tomorrow. All right, we're going to finish this up here. I know we said the hour kind of ran out on us, but I got to finish this problem before we record day 1 here. All right, so we made a big green triangle, or big green square here. All right, and this green square is 1, 2, 3, 4, 5, 6, 7. So it's a 7 by 7. So that means its area is 49. And the areas of these huge long triangles are 1 by 6. So half of 1 is a half, and half of 6 is 3. So this is an area of 3, these super, super long triangles. So again, 4 times 3 is going to be 12. So when we subtract 12 from this, we get 37. So if the area is 37, that means to find the side length, we can square root it, and it's not a perfect number, so we're just going to leave it as a square root of 37, which is a rational number, a decimal. All right, so the area of the small was 13, the area of the medium was 37, and now the large, and this is probably going to be the toughest one to see because we got a lot going on in here. But so what I'm going to kind of try to do to kind of help matters out is erase these other triangles just so you can see it. All right. So your paper doesn't have, but here it is right here. Okay. And we're going to make this smaller. So again, the slope here is we're going down 2 and over 1, 2, 3, 4, 5, 6, 7, 8. So negative 2/8, which is negative 1/4. All right. So the slope, the negative reciprocal of negative 2/8 is 8 halves. So we're going to go from this point and go up 1, 2, 3, 4, 5, 6, 7, 8, and over 2. So I actually have to make some more dots here. And 1, 2, 3, 4, 5, 6, 7, 8. Got a dot there. All right, so there is the square. And if I go ahead and every time I erase, I keep losing my pen here. And I'm going to box in the big square. We're going to go up an extra row here. All right, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and the next row is 10. So this is a 10 by 10. So that has an area of 100. And if we look at these squares here, this is a 2 by 1, 2, 3, 4, 5, 6, 7, 8. So this is a 2 by 8 triangle. So that means that each of these are half of 2 is 1. 1 times 8 is 8. So these are 8. And there's 4 of them. So these are 32. So 8 and 4 triangles is 32, which means we come with an area of 68. And if you notice, this has an area, a side length of the cube root of 68. So we kind of come up here. If we look at the difference, the right triangle had all 4 sides. Or I'm sorry, all 3 sides of the triangle were whole numbers, right? Perfect squares. And if you notice, the acute one had one that was a nice square. The other one were square roots. Well, this one, because this is not a right angle, and the reason being is, if you take a look at this side, which this side would be the right angle, right? This has a slope of 1/7, and this has a slope of negative 3/2. Well, negative 3/2 and 1/7 are not negative reciprocals of each other. So this is not a right angle. So this is obtuse. And if you notice, the obtuse triangle has all 3 sides are square roots or irrational numbers, decimals that go on forever. So we're going to stop right there, and this will be day one of the 3.1 lesson.